Hi, welcome in day 6. Today we're going to discuss collections, list, and a set. So let's get started. The collection in Java is a framework that provides a facility to store and manipulate the group of objects. Java collections can achieve all the operations that you performed on a data such as searching, sorting, insertion, manipulation, and deletion. So collection is an interface and there are two further interfaces that are going to extend the collection interface. One interface is called set, another is list, and there are multiple classes which are going to extend the set interfaces and list interfaces. The classes which are going to extend set interface are HashSet, TreeSet, and linked HashSet, and the classes which going to implement the list interface are ArrayList, Vector, and LinkedList. In next slide, we will see one by one what is the difference between set and list, and then what are the differences between the classes which are going to implement the set and list. So first, the difference between list and the set. So the list in general is unsorted, is ordered, and the duplicates are allowed. So when we say it's unsorted, it means if you add the element, they are not going to be sorted. So the way it is added, when you retrieve them, they will be in the same order. So the order will not change. So they are unsorted, and ordered means like when you add, say, at index 0, index 1, index 2, index 3, because they are unsorted, so their order will not change. So they will be ordered elements, and then the duplicates is allowed in the list. Whereas in set is sorted in some way. We will discuss how the set are sorted. So because they are sorted, so they are called unordered, because if you put something at index 0, 1, and 2 and 3, after adding those, the when sorting will happen, they will not be in the same order. So they are called unordered, and the duplicates are not allowed in set. So in a list, we have seen there are three main classes which are going to implement the list interface. The first is ArrayList. ArrayList class implements list interface and it is based on an array data structure. It is widely used because of the functionality and flexibility it offers. ArrayList is a resizable array. So the thing is in normal arrays, there's a fixed size. So let's say you define the size 100, and if you put 100 elements, when you're trying to put 101 elements, it will throw an error, right? Because the maximum space allocated for that array was 100, and you cannot extend that size because it's a fixed size arrays, and the array lists are flexible. So once, let's say you define the size 100 for array list and then you want to put 101, it will automatically expand its size, and normally it's expand its size in double. So let's say you define 100, and when it's reach 100, it will automatically double itself, so you can put more elements in it. So that is the dynamic resize array. It implements all optional list operations and permits all elements including null. Vector class, again, it implements the list interface. Vector is very similar to ArrayList in functionality, but it is synchronized and thread safe. And what it means by synchronized, it means when you're trying to add element or remove elements in a multi-threading application, when the one or more than one threads are going to approach that vector and they want to add something or remove something, then the first vector which is already adding, it will be inside the method, and the second vector which trying to approach the same method, it will be blocked for some time until the first thread finish his job, came back from that add method or remove method, and then the second thread will be allowed to go inside and perform the operations. That's called thread safety, and we can get thread safety by synchronizing that method. So vectors are synchronized. Because the vectors are synchronized, when they are in a multi-threading environment, you find that they are a bit slower than ArrayList, because they are stopping threads to approach to the add and remove methods. But on the other hand, they provide a security that not two threads are going inside the method and changing the values. The linked list is a class which again implements a list interface. The elements are linked using pointers and addresses. Each element is known as a node. Due to the dynamicity and ease of insertion and deletions, they are preferred over the arrays. So in next slide, we will see what is the difference between array list and the linked list. It also has a few disadvantages, like the nodes cannot be accessed directly. Instead, we need to start from the head and follow through the link to reach to the node we wish to access. In case of you need to add something, uh, addition is easy, but then you need to transverse through the nodes, because either you are on the head or you are on a tail, and you cannot be somewhere at some index point just to making that changes or manipulation. So that's why it's a bit slower than array list, but there are few advantages of the linked list over array list, and we will do comparison on it. So how we define an array list? So it's very simple. So we say array list, and then we say new array list, right? So this is the list name, and then this parameter is going to define what will be inside the array list. So here we're saying a string will be inside array list. So now if I try to add ALS dot add something boolean or integer, I will see an error because I already specified that the array list will only contain strings. So now I'm going to add the elements into a string. So the AList is the name of the list we defined here, and then dot add is a method which is going to add an element in it. So we're trying to add an element: Steve, Tim, Lucy, Pat, Angela, and Tom. And after that, we're going to print that list. And then later, we're going to add one more element, and then we're going to print it again. So the output will be the first putting the Steve, Tim, Lucy, Pat, Angela, Tom. So that's from this output is coming from this statement, and then we're adding a Steve in it. So we're adding a Steve at index 3, right? So this is 0, this is 0, this is 1, this is 2, and this is 3. So this is index 3 where we're adding a Steve. So it will be coming to the same place, and then adding the Pat, Angela, and Tom. So it's not going to remove the existing element. Instead, it is going to place at that third element, on the third index, the Steve, and it's going to move or push that remaining elements to the further places. So now the Pat will be at index 4. Previously it was at index 3, because we put something in index 3 elements will be pushed further, and the list itself will grow. So the array list, in array list, if you want to sort the elements, we can use the method come from the collection. So collection dot sort, and then inside that sort method we pass a parameter which is a list. If you want to remove an element, we say list dot remove method, and then you specify which element you want to remove. If you want to find the position of certain element, so you can get index of and then provide the element in it. So the list dot index of Tom or Steve, whatever it is. And then if you want to find out if the list contains specific element or not, you can use the method called contains. Okay, vector implements list interface. Like ArrayList, it is also maintains insertion order, but it is rarely used in non-thread environment, because the vector is used for multi-threading environments where more than one threads are there. So we need to synchronize or secure our um, um, the elements we are adding in it or removing from the list or from the vector. So as it is synchronized, and due to which it gives a poor performance in searching, adding, deletion, and update of its element, because it is stopping threads to going inside those methods, like adding is a synchronized, searching is synchronized, delete and update. The all methods are synchronized. So only one thread can go perform the methods inside, come back, and the next thread will go inside. So that's why it's a bit slower in performance. So how we define the linked list? So the linked list, we say the class is linked list. What type is going inside that class? And then the new linked list, again the same type should be specified here. And then we're going to add the strings in it. After that we're going to print that, and we're going to remove those and then print it again. So in the first place we put A, B, C, D, right? So A, B, C, D, and then we said at index 2 we want to put E, and then we say okay, they remove B3, the first element and the last element, right? So you can see the output D, A, E, B, C, and then we remove the element from out of it. Okay, so now the interesting fact, the difference between array list versus linked list, when to use array list and when to use the linked list. So in array list, sometimes assertion is slow in array list because it need to resize itself, because when it's reached to its size, as I mentioned earlier, let's say the size is 100 and it's reached to that size, it need to resize dynamically to double its size. And when it's trying to double its size, it need to do some shifting in the elements as well. So that's why it's at that point it's slow when it's reached to the maximum capacity and need resize. In the linked list, there is no resizing required. In ArrayList, the get method, the response of the get method is big notation O1. So let's discuss what is the capital O1 or big O1 and big O-N. So the big O1 means the constant time independent of number of items, right? So the time will remain same if you do a get operation regardless how many elements are inside. So let's say you have 100 or 1000 or 10,000, it doesn't matter, because it is not dependent on the number of elements. It is a constant time. And big O(n) means it's proportional to the number of elements. So if you have 10 elements, so the time it consumed, it will be then according to the number of elements. So 10 elements, say for example, I give an example, that 10 microseconds. If it's 100, it might take 100 microseconds. If it's like 1 million, so it might take 1 million microseconds. So it's just an example, just a rough idea, just to illustrate that what is the difference between big O1 and big O(n). So the big, so if you in a very simple way, the big O1 is the fantastic thing, and big O(n) is not a good thing. So we shouldn't have big O(n) scenarios. So we see the get have big O1, addition have big O1, the removal have big O(n). So see here, if you have something like criteria where you need to remove so many things, then using an array list is not a good idea. On the other side, the linked list for the getting an element, because we need to transverse all the way from either from head to tail or from tail to head. This is proportion to the number of elements inside it. So the get is a very expensive operation, whereas addition is not expensive operation, but searching the right node where we need to add it is a bit expensive here, right? And then removing is not expensive, whereas ArrayList is expensive operation because it's depend number of elements in it. But in a linked list, it is not expensive at all. So what we learn from this comparison, so use when excessive get calls required. So when you need to have so many get calls, your APIs or something, your operations are just calling things, and you need to just get an elements from the list, then ArrayList is the preferred way to store an elements, right? And when you have more deletion is required, for example, you want to delete something from the database all in once, or maybe the client want to delete all his data from the database. So what you need to do, you need to fetch that data into the linked list, and then you remove from that linked list and push that linked list back to the database as an empty list. So in that way the linked list is a preferable idea. So in ArrayList, the manipulation with ArrayList is slow because it is internally use an array. If an element is removed from the array, all the bits are shifted in a memory, because we have seen, like, when we add something or we remove something, it need to maintain that index, right? So if you're going to put something at index 0 or index 1 or index 2, index 3, let's say you're putting something at index 3, right? So when you put something at index 3, there was already something at index 3 and index 4, index 5. So what it need to do, first adding that element, it need to shift those elements which are already on that space further, right? So it shift 3 at space 4, 4 at space 5, and index 5 at space 6. So it need to shift all the way the elements and then insert your element where you ask for. But in the linked list, because they are nodes, they are not as such on the index space, so the no bit shifting happens, right? You said I want to put something a specific point. For example, just take an example. So this is one element, this is second element, this is third element, this is fourth element, right? And they are linked lists, so they are joined like this, right? So let's say you want to put some element here, right? And furthermore like that, so you want to put some element. What in if it's an array list, because array list is one list, it need to shift all the elements here further and make a space for you. But in a linked list, what it need to do, it just need to remove that pointer from here. It will remove the pointers which are here, give you the new index here, and then it will create a new one for you here. So because the pointers, they are connected with the pointer, the node with the index, so the node will be easily added here. Nothing will be changed further. Your new element will be added at this point, and the sequence will remain same. So there will be no bit shifting, right? This part will not move, this part will not move, and uh, things will be added or removed where it's required. The only issue is that either you are at this point or you will be at this point and you need to transverse, right? So let's say if you are at this point and you need to remove something at the last index, what you need to do, you need to move all the way like that. You need to reach at this point, right? So that's why the transversing is a bit expensive operation. But when you do the deletion is a cheap operation, because it does not need to do bit operations on the rest of the indexes to move further and insert that element or delete that element. Let's discuss the set, right? What is the set? We already seen the basic behavior of set, and the classes which going to implement the set are, one of them is HashSet. So the HashSet, it is not a thread safe, right? Because the methods are not synchronized. It does not maintain any order. So let's say you add a few elements and you won't expect that sometimes you see when you print out they are coming in the same order you entered, but sometimes they are not, because it does not guarantee any order, and there is a reason for that. So it permits null value, right? Objects are inserted based on their hash code, right? Because they are inserted based on their hash code, and then the hash code method is going to implement that hash code values, and then the elements will be stored basis on those values. That's why there is no maintainability on the order. Sometimes you see the same order they are inserted because the hash code is in the same. Sometimes they are different because the hash code are different, right? So for that perspective, there is no guarantee that the order will be maintained. Yes, but the duplicates values are not allowed. So it is a guarantee that you won't see a duplicate value into the hash set. So the place where you need to add an element and you want to be guaranteed that there shouldn't be any duplicates in it, the hash set will be the good alternative of the list, array list, or the linked list. So how to create a hash set? It's very simple. So we define a hash set. What is going to be living inside that hash set? For example, we say string. We see multiple examples when we do the demo. Rather than strings, how we pass objects in it, right? So to define, this is going to take a string. I will add those, right? And here I'm trying to add a duplicate element because this element India is already specified here. Thus then we need to reconfirm that this won't be duplicate into that collection. So we only have India, Australia and South Africa, and then it won't add India. And the good thing is it's not going to throw an error, right? It won't throw any exception that you're trying to add an element which is already there, you shouldn't be allowed. It's just ignore that. It's just do the comparison and just ignore without throwing any error. TreeSet, again TreeSet implements a set, so the duplicates are not allowed because this is the basic behavior of sets. The value when we add into set, they are sorted on natural sorting. What it means that if your classes or the models, they implement comparable interface and override compare to methods. We'll see more in details into the demo what is comparable and what is comparable thing and how we use that. But just if we need natural sorting, we need a class which is going to live inside the tree set, that it implements a comparable interface and overrides compare to method. So if we don't want a natural sorting, then we need to use comparator and a comparable interface. More in the demo and in the next slide about comparison between what is comparable and comparator. TreeSet does not allow a null value. HashSet does allow you to put a null value, but TreeSet does not. So the how we create TreeSet? So very simple. TreeSet, what object is going to live inside that TreeSet? We're going through the basic example string, but when we do demo, we're going to add further more objects in it, and then say new TreeSet, and the object is going to live inside. Very simple. The same method, the methods are same because they are going to implement the same interface, so we're going to add those in it, and then after that we're going to print out uh, uh, the elements we have added there. So just rough on comparable and the comparator, what is the difference, and more we'll see in a demo. So comparable, it is a single sorting sequence. You define once comparable in your model or in your object class, and then it will be remain same. It affects the original class because you need to make a changes into that original class because it implements comparable, and you need to override a method called compare to method, and in order to use it you say collections.sort, and then you pass the list which you want to sort it. On the other hand, comparator is a multiple sorting sequence. So what you do, you create your own comparator classes. Let's say you want to compare it with the first name, and then for first list or for first set, for other set or list you want to compare the same object but with the last name or with the age. So you can use a comparator because it's called multiple sorting on it. It does not affect the original class because you're not going to touch the original class. Instead you're going to create your own comparator class which implements comparator interface. There is a method called compare method in which you specify how the objects will be compared, and then when you use a collection, so you use a collection.sort, you specify a list, and then you specify the interface or your own class, own comparator class, that how it will be compared to. So let's straight jump into the demo and see how these things work in reality, and then we'll come back with the questions you have. Thank you very much. I've created one main class. Inside the main class there is a void main method, and I'm going to run the separate methods just to demonstrate array lists, the tree list, the sorting mechanism, comparable and comparator all in one. So this is my first method called my array list. Here I'm going to define the array list of type string, which take a string in it, and then I'm going to add few strings in it, right? And then I'm going to print it, and then again I'm going to add uh, at index 3 Steve, right? Then what will happen, the further indexes like these indexes will move further, and the index 3 will be populated with the Steve, and then we're going to print it. So let's run this one. So you see the Steve, Tim, Lucy, Pat, Angela and Tom, they're coming from this list. and then I'm printing it, and then after that I'm going to add it at index 3. So 0, 1, 2, index 3 is this one, and these elements are Pat, Angela, and Tom. They are further moved to the next indexes. Thus, we discussed in a previous theoretical part that when we have array list, we have a bits are moved further to insert an element or remove the element. So let's say if I'm going to remove this element, what will happen? This will not going to be the empty. These elements will be shifted back to take that space, so their index will change, so there is a bit movement will be happen on that side as well. So when we do insertions um, in the middle or somewhere in between or remove something, the bits will move back forward or backward to take the space of the remaining the movable elements. So then we're going to have array list where we're not just passing uh, the the string, but instead of string we're passing an object, the student object we have created. So just see the words how the student object looks like. So this is a student object which has the first name, last name, and age in it. So, and what I'm going to do, so this is going to take students in it, so creating a list which is taking student in it, and then I'm adding a new student in it. So the 3 students are added, right? And let's see how it will come. So I'm going to enable that method here. I'm going to run it. So there are students like named Steve, Tim, and James. So the students which I have added just now, which are Steve, Tim, and James. So if I want to see them in a sorted order, what I need to do, I need to use a method called collection.sort. And let me show you the previous example first, where what we were doing it in previously, when we were having this list, the list of strings. You see, you're getting those strings back, and they're not in sorted order. But when I enable this collection.sort, I don't see any error here. The collection.sort on to the elements which are strings element in it, and I'm going to run that method, and you see they are coming back in a sorted now. So A, L, P, S, S, T, T, right? So they are in a sorted order. So this sorting is happening because of this collection.sort, and this collection.sort on a string is pretty much straightforward because the JVM knows that how to sort the strings, right? But in when we need to sort an object, when we say sort my object, then the JVM will ask, okay, how to sort that object on the basis of what? Because it has a first name, it has a last name, is an age, and they're all different elements. So how should I know that on which element do I need to sort it, right? Should I sort it on first name, on the last name, or or at the age, or a salary? So you need to specify me the sorting mechanism for that, right? So let's this one, and I'm going to run this method, and I say collection dot sort. Now the same method I'm using for a list, but it's giving me an error, right? And it's saying that cast argument a list to the list of type parameters. What it means actually that at the compile time, the JVM is looking on this method and is trying to find out that developer want me to sort it, but I don't know how to sort it, right? So there should be some kind of mechanism, and the mechanism are either we implement a comparable interface or we use a comparator interface to make a comparison. So I'm going to going my student class, and if you remember, we mentioned that if the class implements the comparable interface. So this interface if the class implements that interface, so that will be natural sorting, right? And then the changes are going to be made into the class. This is not external thing, this is one time change we're going to make. And then here we can do a comparison, but that comparison will remain fixed. So if we do comparison on the first name or to the last name, or the combination of first name, last name, or age, or whatever the combination we use, it will remain fixed. It is not a dynamic. If we need to have a dynamic comparison, we need to use comparator. So we'll see that how to use a comparator, but let's go through the comparable interface first. So the comparable interface, you need to specify the object which is going inside the comparable, and then you see the error is here, because errors say add implemented method. So there is the method we need to override, and that method is compare to method. And in compare to method, what I'm going to say, I'm going to make a comparison on the basis of the first name. So I'm saying this dot first name dot compare to with uh, the object which is going to pass as a comparison with their first name. So this O is actually coming from here, and so this dot first name means the class which actually at that point is invoking that method, and this O dot get first name is means the one which is in comparison, which, let's say you have index 0 and index 1. So the index 0 will be remain same, but index 1 will be the point where we need to make a comparison with index 0 with index 1. So that will be the index 1, and then this dot first name will be index 0. So we make a comparison one by one with each element when we do sorting on it. I'm going to save this. When I will save this and save this, you see the error is gone, right? And when I run this, now it's coming in a sorted order. So the James is first, Steve is second, and the Tim is third. Whereas we added Steve as first, Tim as second, and James as third. So they are coming in a sorted order, right? That's cool. So we understand how comparable work. We can do different things with comparable. Instead of having a first name, we can say last name, and then we compare with the last name. We can do with this with the age, salary. We can use any combination here to make a comparison for them. The return type will be integer, so it make a comparison to see if it's greater than, less than. If it's greater than, it is going to return 1. It is less than, it's going to return a -1, and if it's equal, it's going to return 0 back. Let's have a look on the tree set. So I'm going to disable this, comment this, and uncomment this tree set. In a tree set, I have a set take student in it, right, and then the student in it, and these are the students which I'm going to add it. I'm going to print it. So we don't see any error at this point here, right? The compiler is not complaining here, right? But when I run this method, you see everything looks fine, right? So you have these things, everything looks fine. And what is happening behind the scene is using this comparable interface, and natural sorting is happening now, right? So it's not asking you to provide any kind of sorting, it is automatically sorting those for you. So it says putting James first, right, and then Steve, and then Tim. We are not putting any sorting method here, it's automatically sorting for you. Why? Because of this comparable interface. So let's say I'm going to comment this part, right? I'm going to comment this method as well. Let's save it. So I don't have any error. So this is working fine. There's no issue with it. I'm going to run it. Now it is throwing an error, right? So this is a runtime error. And what is happening at runtime is now it's trying to add an element, but it does not know the how to add an element, because it need to add an element because the tree add element in a sorted fashion, right? It need to be a sorted way. And then at this point, it does not know how to sort it because we have not specified how the object need to be added or it need to be sorted, right? So it does not know it need to be sorted on the first name, last name, or the age. It is confused. So when it's run in the runtime, it is throwing an error. So there are two ways of resolving that error. One is the one we have this comparable interface, right? If I uncomment this, initially we have done this and we see there is no error, it will be doing a natural sorting. But that natural sorting is a very static. It's always be going to be sort on the basis of the elements we specify here, the first name, right? We cannot change here. But the thing is, if we need to do comparison sometime on the first name when we adding student object, another time we need to make a comparison onto the last name when we adding to the student, and we cannot make a changes every time onto that student class, right? That's need to be a fixed. So the alternative for that is we use comparator, right? The how we use the comparator, so we create our own comparator class, say first name comparator. Aim implements comparator, and then we specify with the student, and then it has a method called compare. We need to override that method, and inside that method we do the comparison, right? And how to use it. So now instead of doing just for creating a tree set, when we create a tree set, we specify when the elements will be added, what will be the sorting mechanism. So we'll say you need to make a comparison onto the basis of the first name, the class we have just created. So I'm creating a new instance, anonymous instance of my class, of this class, and it has the method compare. All right. I'll say Control S, and then I'm going to run it. So you see now there's no error coming back, and all the elements are added and they are sorted. So that's the dynamic way of making a sorting. So let's say another tree set I'm going to create, and now I need to sort it on the basis of last name or the age. I simply need to create a new kind of comparator. So I say on the basis of last name, right? I'll just create a comparator of it. I will change this to, this is O1 is there, O2 is there, and get last name, get last name, and all done, right? And when I run this, now you see they are sorted onto the basis of their last name. So J is the last name, then K is the last name for the Steve, and then M is the last name for James. So Tim, Steve, and James. You might be thinking that why we having just a first name and we're not having a last name here, and the reason for this, if you see in a student class, we have a toString method, and in toString method we only specify the first name and the age, and we haven't specified the last name. So if I just make a few changes here, we'll be able to see that. So if I say here, we need to see that thing as well. So you just instead of returning that one, you can add one more thing here, the last name, and then element last name, and it will be going to print that thing. So I hope the things are clear for you. Just a quick overview. In array list, we don't need to specify any any way of comparison, because we have a method called sort, and that sort can be done with the objects like a string, without any implementation of any comparable or comparator interface. But where the objects are involved that have a multiple properties, we need to specify on which property we need to make a comparison to add an element or to do a sorting on it. So that's why we need to use a comparable interface, which we have done into this class, right? We said it implements comparable interface, and then we override that method. When we use the tree set looking for a mechanism to add an element in some sorting way. So if you're not specifying that what mechanism to use to add an element while in a sorting fashion, then we see error when we run the project, because the JVM couldn't find a way that how these elements will be added, because it cannot make a comparison between them. So you need to do either use implement the comparable interface, or you can have your own comparators which are making a comparison just via implementing comparator interface. So I hope the things are clear for you. We have reached end of the day 6. Thank you very much for watching, and we will see you in the next lesson soon. Till then, bye.